Hello, today we're going to continue talking about acids and bases by talking about calculating pH and identifying what is an acid and what is a base by looking at the chemical formulas. So make sure that you have your notebook out, label it with today's date as well as this title, and make sure to have your calculator out too because we will be doing some math problems. So what is pH? We've talked a little bit about this. We've looked at litmus paper as well as figured out, potentially looked at pH paper in class and kind of starting to figure out pH can tell us how acidic or how basic a sample is. And more specifically, pH is a part of a logarithmic scale to represent the concentration of hydrogen ions in a solution. And we know that pH runs on a scale of 0 to 14. It is possible that in math classes you've used the log function on your calculator or the inverse log to do certain what's called log problems. And so we're going to be applying some of that knowledge to chemistry to further understand acids and bases and how strong or weak they are in a solution. So here is the pH scale, the relationship between hydrogen ion concentrations, so H plus and pH, and we see that it exponentially increases, or it increases by a value of 10 each time. So notice that like 1 is really the solution is 10 to the negative first solution, and then it increases greater. So the difference between a pH of 1 and a pH of 2 is not simply just like 1.0 molar. It has an even greater impact, and we'll talk about that more in class and why that can be so serious with it. So depending on how familiar you are with the log scale from math, you can kind of start to apply that knowledge here as well as we talk about hydrogen ions and concentrations. Make sure that you have this definition down of what pH is. However, you do not need to write all this down. Why is it important to note this is on a logarithmic scale? We just talked about that. So pH has a logarithmic equation that we'll talk about, and the equation that we'll use is pH equals negative log of the hydrogen ion. So again, H plus is the hydrogen ion. So write this calculation in your notes, and this is how we will calculate pH when given the concentration. So if we put in our calculator negative log of, say, 10 to the negative first, we would get back 0.1. Or 10 to the negative second, we'd get back 0.01. And notice again that the difference between a pH of 1 and 2 is much greater than just 1. It is a whole decimal place. So using the formula that we just talked about, pH equals negative log of the hydrogen ion, we can use our calculator to determine the pH of a certain solution. So we would just plug in our concentration for the H plus ions because this is an acid. So we're talking about only acids right now. So the pH of this 0.056 molar HCl, I would find my negative symbol on the calculator, click negative, and then click log, and make sure you're not clicking minus, you're clicking negative. And the Google calculator should have this as well if you don't have a calculator on you. But to click negative, log, and then this, and make sure to use your exponent functions correctly as well. And if you're confused at all, try your best on these practice problems. Check your work, and then we'll talk about them more in class as well if you're having calculator issues. But again, make sure that it's times 10 to the negative second power. Think back to physics when we did some exponents as well in physics class. And then your final answer, if you hit equals, should be 1.25 for this example problem. Make sure to show these steps in your notes, and we'll continue on to the next one. We could also be given the pH and then find what was the original concentration. Well, we can use the inverse formula to determine the concentration of something. So if we want to find the concentration of a 2.3 pH solution, we would do the 10 to the negative pH. So this is the inverse log, if you remember from math, but I would give you this equation. So write this one in your notes. 10 to the negative 2.3 gives you 0.005 molar. And I can actually go back to the pH scale and see if that makes sense. So 2.3 pH should be somewhere around 0.01 to 0.001. And that was correct because my answer that we got there was 0.005. So it was between those two values. So here are 4 practice problems. This video is not over, but if you could pause the video, work on these 4 practice problems, and then continue on, and we're going to talk about identifying acids and bases. Make sure for these 4 practice problems you show all of your steps in the equations throughout, and then use your calculator to solve for it. Now that you're complete with these problems, we're going to continue on and look at acids and bases. So look at this list. What do all of these have in common? Look at this list. What is different about it, and what do these all have in common? Hopefully you saw that these all have H+ ions, which makes sense because we talk about acids having hydrogen ions to give, and then these all have OH, hydroxide ions in them, and they typically are going to, in a reaction, give that away or want to accept a hydrogen. So we notice that these are all acids, so write these in your notes so you have them to refer back to, and then write these bases in your notes too. Make sure you label the acids, the bases, bases. So now practice for yourself identifying each of these as an acid or a base. Please write the full thing, write the number 1, write KOH, and then is that an acid or a base? And do all of those 6. Pause the video, write those down. Once you are done with that, make sure to take a clear picture of your notes with all the practice problems and definitions, and then upload it to Google Classroom so that your teacher can check through it. And if you have any questions, email your teacher or bring your questions to class next class.